Thank you.
Thanks, Andrei. Thanks for the presentation. Our next topic is the algorithm of iterations of distribution of subtasks between sbot in one warm bot system by Gennady Krivoulya, Volodymyr Tokariev, Iryna Ilina, Oleh Lebediev, and Vladislav Shcherbak. Our authors, are you here? Is there anybody here from the above?
I will be reading the presentation.
You will be the presenter. Okay. Did I call your name? How can we call you? Are you one of the authors?
It's okay. I'm just going to be a presenter. Call me David.
Okay, David.
Yeah.
Then yes. Okay. Yes, please. You can start.
All right. In that case, I will share my screen.
Yes, please.
Screen. 1 second. Right. It should start. Is it starting? I'm a little lost.
It's almost.
Almost.
Yes. Oh, I can see myself.
Okay, perfect. Right, there we go. So before I start, I just want to say the original author of this paper could not attend the conference. So I'll be reading it, but if you have questions, we can write them down and send it to him. And if you want to get in touch with him, we can arrange that. Yeah. Okay.
Yes. Thanks a lot, David. Yes, I understand. Okay.
So let's just start. Right. So this presentation is about an iterative algorithm for distributing tasks between sbots in a swarm bot. Now, what are swarm bots? Swarm bots are a technology that's been around, but which is increasing, and they're used in many diverse fields, from defense manufacturing to green energy, robotics, biomedicine, and other. They read sources of information. They have intelligent embedded systems of control, and combine environmental factors to complete tasks. This paper wants to look at the use of a central particle swarm algorithm that will effectively delegate tasks between sbots in such a swarm bot system. So what type of problems do these swarm bots solve? Usually tasks related to gathering data on large areas and structures. This could mean anything ranging from fields to any kind of abstract system that uses separate nodes. For example, CPUs in a multiprocessor system, that can be considered a group object suitable for swarm bots to complete tasks in. And what do these swarm bots do? Well, they can act individually to complete a task. They use strategies for interacting with each other in real time, and make use of autonomous actions, planning, impacts on the environment, and purposeful problem-oriented judgments. Some Ukrainian scientists, such as Dodonov, Gorbachev, sorry, I can't read his names, Dodonov, Gorbachev, and Kuznetsova, published works in this, relating to the difficulty of achieving the most efficient kind of mobile units. So how can these mobile units organize themselves? For inspiration, we can look at many social, natural systems, and even systems in other technologies, which make use of controlling a large group of independent actors to achieve an effective completion of the mission. So, for example, quite a simple one is a herd system, where swarm bots sbots make decisions independently, exchange information with each other, and form their own strategy based on their own history, and each fulfill their own task that fits into one global mission. The tasks are simple, and the sbots try to optimize their individual solution of the task rather than optimizing the whole system. In such a system, all sbots are equal, and losing one or two does not compromise the overall mission. And the group can increase its survivability without much additional cost because of the decentralized control arrangement that happens here. But this does require difficult algorithms, and it's quite difficult to achieve optimal solutions. There's two types of swarm algorithms. You have a swarm particle algorithm, which will be the focus of this paper, and an ant colony algorithm. These are used to solve harder optimization problems than the herd algorithm. The main challenges are tuning and adapting to the specific optimization problem and selecting the right weighted coefficients. And scientists such as Dorigo, Kennedy, Shi, and Eberhard have discussed these before. So let's try to understand how an sbot sets up its missions and solves them. We have a set Z of subtasks, which are necessary to solve some kind of global mission. Then you have a set B of all of the sbots. Next, you need to consider the reward matrix. The reward matrix is the reward that an sbot gets by completing a certain subtask. And in opposition, the cost matrix, which is the resources an sbot spends by completing the same subtask. Then you need a matrix of possibility, linking up which sbots can complete which tasks are able to be completed, and so on. Now we take these sets we've introduced, and they are combined into one equation you see here, which aims to solve the global mission Z while maximizing gain, and the gain is X. And you can see we need to consider everything we just mentioned: the amount of tasks, the amount of sbots, which sbot can complete each task, the rewards and costs of this. The results is best stored in an array. The array has a number of elements equal to the number of subtasks, and each element number represents the task, and the value of each element represents the sbot assigned to it. So, for example, you take you'd have an array such as 3, 1, 2, which means that the sbot number 3 will solve the first subtask, sbot number 1 will solve the second task, and sbot 2 will solve the third task. This is just how the results are presented. So, getting closer to distributing the subtasks and understanding the central particle swarm algorithm, you have a standard deviation of a random I particle and the corresponding equation for it. You have its variance, and the variance, standard deviation and variance, makes use of two more quantities. One is the mathematical expectation of a random particle I, and the probability of the appearance of this particle, which you can see at the bottom here is P is equal to y over n, y over the total number of values. So here is the crux of the paper. This is an iterative algorithm which aims to being investigated. It's made use of 4 simple iterations. The first one is an initialization. You have a random swarm with randomly positioned bots with random speeds and random directions. The next step, iteration 2, is calculating the best value of the objective function, considering the distance between the sbots and the destination points, and making a conclusion about the best local and the best global solutions. Next, iteration number 3, we apply the classical particle swarm algorithm formula to correct the position of the sbots and make sure they're not out of any search limits. This is what the formula looks like, and you can see the values it considers are the speed and positions of some random ith particle of each ith particle, U1 and U2, which are weight coefficients for the local and global solutions, P best, I apologize, it's underlined in red, so you actually can't see it. Let me just quickly go into present mode. Oh, no, that's not good, is it?
Oh, it's much better.
Is it sideways or is it not sideways?
It's much better because now it has the full screen and not this small part as it was before,
Right.
but it's okay.
Well,
I'm
okay. Sorry if the text has been
yeah? It's okay. It's okay.
Yeah. Right. So yeah, you can see this equation considers the weighted coefficients and P best and G best, which are the best solutions determined by a random ith particle, the local optimum, and the global optimum, which is the best solution among all particles of the set, and also a random number. And finally, iteration number 4 is very simply checking if the conditions for stopping the algorithm have been met, for example, the desired accuracy. And if they haven't, then we go back to iteration, and this is the algorithm. Next, the author conducted an experiment and worked out some numerical values from it to give you an idea of the performance of this algorithm. So, for example, this graph shows the number of particles in the swarm and the root mean squared deviation produced, the number of iterations used in this algorithm and the root mean squared deviation, which you can see decreases the increase of iterations. And finally, the number of tasks which the system has been given, and the root mean squared deviation. So what is the conclusion of this research? Well, it's a centralized particle swarm algorithm has been applied to a swarm bot system and successfully solved. We can say that this iteration algorithm has quite easy operation, only a small set of input parameters, which you set at the start, good accuracy, and quite encouragingly, a fast convergence to making the optimal decision. Some future research which could build on this would be to make a genetic centralized algorithm and a comparative analysis of other algorithms suitable for swarm bot systems to determine which is the best one for all. Thank you all.
Thank you, David, so much. Maybe there are some questions for David. If not, then I have
again.
Okay. Okay. So if there are some questions, then I believe you might ask. I see. You will use to stay in touch with the authors. Okay.
Yes,
if there are some questions, maybe someone wants to ask a question. Well, maybe I will ask then, are there any operational analysis algorithm methods that authors used or consider to use?
Okay. Yeah. Thank you. I'll note that down.
Okay, maybe that's probably the only question for now. Well, we can see the presentation. We can see the presentation in our special Google disk guide folder. So we might contact authors and ask them questions directly. Okay, if there will be any answers, then I will appreciate it. Thank you very much, David, for the presentation.
Yeah. Thank you for listening. Sorry for the unusual arrangement. Yeah. Cool.
Thanks a lot. Okay, David. Thank you for the presentation. We might go for our next presenter. The topic is the concept of using artificial intelligence methods in debt financing of business entities. So probably Olha Kots will be the presenter, one of the authors.
I will be. Yes,
I guess. Lucky me. Olha, please, the floor is yours.
Thanks. I would like to present our research, and we tried to combine in our research the artificial intelligence methods and business financing, especially debt financing, and try to find something what connects these two categories, interesting categories. Why did we decided to do such research? Because we have many changes in financial sector. We have the development of cloud technologies in finance, data analysis system, artificial intelligence, digital virtual assistants. So many new informational technologies are now applied in financial sector. But if to look at the Ukrainian evidence, it's not really wide used. So we have the sphere for analyzing, for research, and for implementation in the future. The COVID-19 crisis has speeded up economic digitalization, so we have new technologies, especially in financial sector. And I think that all of you more often use web applications or mobile application, but not go to the bank and not visit bank workers. I have to say that global spending on artificial intelligence in 2020 amounted to $50 billion, and by 2024, such costs will double to more than 110 billion United States dollars. And from year to year, such methods like artificial intelligence methods are increasingly being implemented in finance. And according to Forbes, 70% of financial companies use machine learning to predict cash flows, adjust some credit ratings, detect frauds, but we still have many possibilities to implement such methods. So there are a lot of literature about artificial intelligence methods, but not too much research is connected to the financial sphere, but they are. So very interesting research is by Yin Shi and Xiaonie Li, based on an analysis of the scientific literature over the past 50 years. And the main conclusion of such research is that such topic is interdisciplinary, and our author collective is also interdisciplinary, and we tried to combine our knowledge to create our research. The main studies in this sphere is connected to the fintech technologies, fintech methods, to blockchain methods. And there is now researchers which propose artificial intelligence methods in debt financing of business entities, because if they are connected to the state level, but for us it's interesting to lower down to the corporate level, and it would be interesting to work in new way in such sphere. So the most common are the following approaches to understand the meaning of artificial intelligence. You can see them on the slide. And the basis of understanding the essence of artificial intelligence is the ability of machines and programs to analyze the information. And as today we have multiplied information year by year, it's difficult to people to do it by their hands. And we need new techniques and technologies to analyze. So artificial intelligence system, machine system, which with different levels of autonomy, which can make predictions, recommendations, some model solutions, and what is the main interest that they can be used in different contexts, using different types of data, different models for performing different tasks. So in financial sphere, it's a really good way how to combine the information for different users in different ways. Next, I would like to show you the criteria for the concept of using artificial intelligence systems. It is closely connected to its life cycle, because in life cycle we will include planning, cooperating, data collection, some verification, deployment, and so on and so on. So life cycle is one of the basic steps to analyze different processes, especially if such process is realized during some time period, and it's necessary to look at it not at the same moment, but for some period. The life cycle of an artificial intelligence system is unique because artificial intelligence system can interact with a real or virtual environment and learn by improving the dynamics, being non-linear and working with different components and to work in autonomy regime. Here we would like to show you some statistics because businesses that make the best use of artificial intelligence methods can achieve the most significant improvements in debt financing operations. In 2020, business entities began to borrow heavily because the COVID-19 was almost in the past and they needed costs to develop their business. And here are results of survey of 622 representatives. It's ready results, not made by us. What's interesting to say what the main areas where financial activities digitalization initiatives was implemented after the COVID-19 because COVID-19 stimulated such processes. The main task of artificial intelligence system in the field of debt financing you can see on the slide. So here's the list. I will not read, I just want to say that Ukraine has declared an innovative strategy for the financial services market development. For this, it is really necessary to pay maximum attention to the potential of using artificial intelligence system because it's innovative tool, it's innovative approach to organize the financial services. And if you want to develop a financial market at all, we can help to every participant to make their life easier, more comfortable, and to make the solution in financial sphere more accurate on how to say. Here you can see a few examples of the use of artificial intelligence methods in debt financing. In article, we have much wider list. If you like, I recommend you to read. I collected it from different sources. And in most cases, debt repayment strategies remain complex, ineffective, and outdated. And the first users of artificial intelligence technologies already see significant payments in their loans portfolio, confirming the feasibility and effectiveness of using such methods in debt financing. Because we have to remember that in debt financing, we can be involved from the both sides. We can be borrower, we can be lender. And if you are talking about business entity, it always needs money or it sometimes has too much money. And the best strategy is to place them, to work with them because money must make money and it's the rule of the economy, of the effective economy. Here is the scheme which is proposed to use like an algorithm of pricing on bonds using artificial intelligence methods. So we include artificial intelligence methods for analyzing information. But it's just for that needs when you want to buy bonds or when you want to place some bonds at the stock market. It's commonly used in highly developed countries, but in Ukraine we have really problems with its implementation. We don't have good base, we don't have software, so it is really the way to develop. So we tried to adapt the general scheme to our Ukrainian needs. Tried to show where to get information, to analyze possibilities of debt financing involvement, and so on. Such algorithm include real data, include model data, and include predictions to say us what will be the price of bonds, for how price we can buy them, how we can place them at the stock market, and so on. So the impact of the use of artificial intelligence methods on the business entities in financial sector, we generalized this slide. and have to say that the use of artificial intelligence methods in debt financing of business entities will reduce the cost of credit underwriting, promote continued cooperation with customers, increase the efficiency of data processing, to assess the creditworthiness of borrowers, improve loan portfolio management, and so on. Here I presented the main benefits of using artificial intelligence methods in debt financing. It's connected to bonds and led us to see what is the key benefit according to business objectives, business goals in this way. The next slide shows us the differences in directions of using the artificial intelligence methods in debt financing according to the management levels. So we have level back office, middle office, and front office, and how we can use the different methods connected to debt financing to analyze different income data to make solutions, our decisions connected to involvement or lending some funds. On the next slide, you can see the relevant issue and risks stemming from the deployment of artificial intelligence in debt financing. There are such main threats to the impact of artificial intelligence on the financial sector, like erroneous algorithm for selecting financial indicators, threat to national and financial security in the event of cyber attacks, loss of control over the activities of financial market entities, a reduction of number of employees of financial institutions. In addition, the increasing use of artificial intelligence methods in the financial sphere creates problems with informed consent. And have to add that any system built the artificial intelligence in the field of finance needs people's control, because not always technical laws work in the economic sphere, especially in financial sphere, but at the end we can lose a lot of money. So we have to really good analyze what spheres we can automatize, which we don't need, don't have possibility to make it by using computer technologies, but human factor has to be closer, shorter, and less used. This slide shows us conclusions of our research. So as artificial intelligence and machine learning methods increasingly modernize debt repayments, both lenders and borrowers can reap significant benefits from using these innovative technologies. So we would like to develop such technologies at corporate level for using debt financing at for corporates, and for promoting corporate debts usage in Ukraine, because now it's really low developed. The use of artificial intelligence analytics should meet the goals of the business entity, because before using this innovation tool, it is necessary to assess the current state of artificial intelligence capabilities and determine the roadmap for the use of artificial intelligence methods by a particular business entity for specific purpose. Also, it should be noted that the use of artificial intelligence method is individual and quite personalized, because it involves making their own decisions based on generated by artificial intelligence proposals. So to get tangible results from the use of artificial intelligence, businesses need to be paid to forming decision-making models, implementing best practices in engineering, in data science. So we have a lot of possibilities, but less results in such sphere, especially in finance. So we have to develop. It's enough developed at banking sector, but really low developed when we are talking about corporates. Artificial intelligence methods will help business to develop also to control the debt financing, to monitor the ability to track debt financing and place funds in debt securities, because it will be easier to make decisions, and such decisions will be more accurate. And the use of artificial intelligence methods can significantly reduce standardized and repetitive work, which is growing, and knowing that we have a huge amount of information, huge amount of data for analyzing, we have to standardize and to do this work to the machines, not to people. Let people just to think, and let artificial intelligence to help us. And I hope that in the future, after the war, Ukraine will continue rebuilding of our financial sector, and we will see it in the high developed level with using artificial intelligence methods. And that's all in my presentation. Thank you for your attention.
Thank you, Olha. Maybe there are some questions for Olha. While our colleagues are thinking what to ask, I hope, well, I believe your words will come true very soon.
I hope to.
We all hope to. Okay, I believe there are no questions for Olha. Okay, Olha, thanks a lot for the presentation. Thanks a lot. You give us a lot of things to think about. Thanks a lot.
Thank you. Let's hope for the nice future.
Yes, it definitely will. There's no other chances. Thanks a lot. Okay, thank you, Olha. Our next topic is the similarity-based fuzzy logic modeling for the software reliability assessment. The authors are Svitlana, Yaremchuk, and Vyacheslav Kharchenko. Do we have authors here with us?
I'm Vyacheslav Kharchenko. Hello.
Hello.
A few minutes ago, I called Svitlana Yaremchuk.
Mm-hmm.
She has a problem with presentation because I have not power consumption. Can we use video, and I could answer on questions.
Okay. Do you have this video? Can you start this video, or should I?
Yes, Svitlana sent this video to you. Please.
Okay, I will
start this video.
Okay, then I will need some time to start it.
Okay.
Okay. So then we have a short break. Well, just wait a couple of moments. I shall find this video and put it on. Start it on.
So sorry for this situation, but it is.
It's okay. It's okay. It's not the worst problem we have now.
Mm-hmm.
So let me check if I have it. Oh no, I don't. Similarity-based fuzzy logic. Yes. Allow me to share it. Just a second. Okay. I can share it. Share the screen like this. Here's the presentation, but I will ask you to tell me whether you can hear it or not. Just a second. Share sound. Can you hear it?
Yes, we hear.
We offer to your attention report similarity-based fuzzy logic modeling for the software reliability assessment. On this slide, we can see the motivation of this research. Software properties are evaluated by different quantitative and qualitative indicators. Assessment dimensions are fuzzy and overlapping. Because the creating of the fuzzy inference reliability model for the software system is relevant in important task. Of this slide, we can see the key publications about using soft computing for the predicting software reliability. We have not found any information about the using similar software systems to build fuzzy reliability models and about the using these models to predict the reliability of newly created system. We call software systems that have similar properties as similar ones and assume that similar software systems have similar reliability. On this slide, we can see the purpose and tasks of the research. Our goal is to build the fuzzy inference reliability model, for short we say firm, for the similar software system. On this slide, we can see research tools. We use the Mamdani algorithm from the analysis environment MATLAB. We use data sets. We did the statistical analysis of the data set. We define matrix estimators as model input variables. The number of false in the module as the output variable. We formed fuzzy logical rules. On this slide, we see examples of logical rules. On this slide, we can see modeling results. In a module with matrix estimators on RFC metric 46 and metric WMC 18, the most probable number of false is about 2.37. Using the model, we can find out the number of false for each module of the newly created system on base the similar system. The number of false can be used by quality experts during software testing. On this slide, we can see dimensional surface of the number of false in software modules. The surface illustrates the tendency of the number of false to grow as matrix estimators increase. On this slide, we can see the chess chart. This chart shows multi-colored areas with numerical estimators of the properties of modules and number of false. The most defective modules are in the yellow area. On this slide, we can see discussion questions. Experimental data are incomplete for natural reasons. Modules with some matrix estimators in the system, in the software system, may simply be missing. Incomplete experimental data can be supplemented in two ways. Firstly, by use of expert knowledge. Secondly, joining of data sets of two or more similar software systems. On this slide, we can see the proposed approach to software reliability assessment on the firm known matrix estimates and known false number for a similar system. On this slide, we can see conclusions of our research. D-fuzzy inference reliability model has been developed. The firm build technique is described. The approach of predictive estimation of reliability of a newly created system based on the firm and data of a similar system is described. Computer experiments have shown the possibility of applying the developed model in practice. The firm and the approach will increase the effectiveness of the software verification. On this slide, we can see further research. The development of firm consists in increasing the number of input variables. It is possible to automatically extract fuzzy logical rules from data set and import the rules into MATLAB. The report is finished. Thank you for your attention.
Thank you so much. I have stopped the sharing. Maybe there are some questions for our authors. One of them is here with us.
Yes, welcome if you have questions.
While our colleagues are thinking what to ask, may I be the first? Vyacheslav, what kind of data you were analyzing? Was this a kind of a survey or it's open data? What kind of data you used in your research?
We use in general, we use a few different kinds of data. First one is information about similar software. I mean, similar software for which we can calculate metrics of complexity to predict reliability measures. Yes, it's first one. Second one, we used information about faults statistics for the such similar software which can be used to predict reliability measures for developed software.
So, you created this data. I mean, it's not somewhere in an open access. It's your data.
No. We use open data as well because we applied similarity principles. What does it mean? Similarity principles is we develop special criteria when we can use similar program, similar software to use data about complexity, about reliability, about fault data set to use for developing our software to predict reliability measures.
I understand. Yes, thanks a lot. Thanks a lot, Vyacheslav. Thank you very much.
Yes, thank you for your attention, for your question.
Okay, if there are no more questions, then thanks again, Vyacheslav. And we skip for another presentation. It's about it is a research on digital analog conversion method for reproduction of mechanical oscillations. One of the presenters, are you with us? Are Stanislav, Danylenko? Yes, you are one. You are the author of the paper. Please, the floor is yours, and then we will ask questions. Please share your presentation. Yes.
Can you see?
Yes, we do.
1 second. So I want to present you research of digital analog conversion method for reproduction of mechanical oscillation did by me, Alexander Vechur, Mariya Shirokopetleva from Kharkiv National University of Radio Electronics. Sorry. The problem that there is a group of people around the world who have hearing problems and cannot receive sound information from the outside world in the usual way. It's not always possible to solve their problems with the help of hearing aids or other currently known tools. The related researches we investigated is about microwave auditory effect, piezoelectric effect, and perception of sounds through the outer and inner ear, spectroanalysis with usage of window functions and Fourier transforms, sound recognition system based on neural networks, and digital to analog conversions at microcontrollers. We propose to investigate alternative way of transmitting sound by airflows generated by fans and recognized by humans by means of skin. For this, we propose to create a software-hardware complex for generating airflows with special digital to analog conversion and conduct experiments with humans and a software classification system. The criteria for evaluating the results is a level of successful identification of the class of original sound. The experiment will be done different count of sounds and duration of sounds, and the threshold level of positive identification is 75%. The general flow of working of our software hardware complex started from getting the data from the source. It can be obtained from the microphone generated by computer or get from the audio file of audio format. Then we generate stream of digital audio data and process it by the algorithm. Then we transfer it to the data to the device with the fans and perform digital to analog conversion, which producing airflows which interact with human skin. Human knows the scheme of fan's location and the frequency ranges that match for the fan, and can understand which sound, which class of sound was reproduced by the fans. We use 9 Delta Electronics fans for our experiments. So the algorithm contains standard operation and self-developed operations. Let's take a deeper look into this. So the first step is using standard library for getting audio stream. Then we calculate average value from the all channels at time point, apply Blackman and Blackman windows and Fourier transforms. Then we apply smoothing over time frequency data and convert it to decibels in range from 0 to 245. Then we filter data after Fourier transform and divide it into the ranges. Each range corresponds to the particular fan. Then we find the most common value at each range and convert the value to the range from 0 to 9 and add the prefix of the fan. Then we send the data by the HTTP request via network, and the end divide we extract the prefix and the value. Then we perform scaling and call the Arduino pulse width modulation function to produce the airflows. The steps of the algorithm takes place in the different nodes of this software hardware complex. For example, all the calculation took place on the client device, then it sends the data via HTTP in the JSON format to the server. Server is the intermediate node who established the connection with the Arduino in device and sends the data in the byte format. Arduino do the pulse width modulation and control the speed of the fans. Here you can see the standard flow of the processing. Client starts the processing, sends the processed data through the server to the Arduino. Arduino do the PWM control and return info about fan state. Then the server sends the logs about complex state to the client that show the logs for the client. So the software part was developed using such technologies. The hardware part looks like this. And the UI contains different elements, for example, for visualization, the time domain and frequency domain, it's 0.1 and 2. also two-dimension visualization 0.7 and third-dimension visualization 0.6. Also, it allows you to select the source of the audio stream. It can be a oscillation microphone and file, and do the general operation. It's 0.4, and also shows you logs. It's a 0.5. So let's move to the experiments. The computer experiments is for the classification based on decision tree and ID3 algorithm. The data was saved to the CSV file during complex was working. It was done for the 5 classes of sound, and the training sample contains 20 items for each class, totally 100 training items. The item represents a set of 440 numeral values in a range from 0 to 9. The test sample consisted of 5 items for each class, but we got the 0% of successful classification is totally negative result. Let's move to the experiments with human. The first experiments was a training. The purpose of each was to remember which fan corresponds to a specific frequency range. The number of participants was 5. The number of attempts at each stage was 2. You can see the plus is positive result in the table, and the minus is a negative result of the identification. And the most common value is 80% is a positive result. Let's move to the main experiments with the recorded sounds obtained from the MP3 format file for different count of sounds and duration of sounds. And we can see the positive result was for the set of characteristics for count 4 and duration 5 seconds. And about the positive results was the set of characteristic also for the 5 sounds and the duration of 2 and 10 seconds. In this slide, you can see that some sounds that is not similar in the real life can produce almost the similar result after the processing with our algorithm and software hardware complex that can produce the problems of identification the class of initial sounds by the humans. So, and the next steps of our research is to investigate the optimal size, power, number of fans and their location, the best human's body part to interact with, reducing the impact of external factors such as wind, usage at commercial segment, and effectiveness of work with military-themed sounds such as bombing sirens, military aircraft and helicopters, and so on. In the conclusion, this alternative method for the reproduction and transmission of sound waves by means of air was investigated. Software hardware complex was developed. Experiment with classification software system based on decision tree model and ID3 algorithm has negative result. But for this task, it's necessary to use more sophisticated approaches. An experiment with humans has shown partial positive result. Reproducible sound can be identified for specific set of sound count and duration. A small demonstration of work with our complex for the sound of tennis play. And thank for your attention.
Thank you so much. I like your presentation very much. Maybe there are some questions for our presenter.
Have you tried to patent your results of your research?
For now, we didn't do it, but maybe in the future.
Thank you. And I want to ask about decision tree and how you use this option and the goals. Why you have this?
We tried to understand, can we use the result of the production by airflows? Can it be obtained by the other software system by to investigate it like an alternative way to transmit the sound not only for humans, but for the different, computer devices, for example, to do the more general investigation.
Thank you. Thank you. Ilan?
Thank you so much. Maybe more questions? No. Well, we have all the information we need. We have all the addresses. We can contact our authors if we will have some additional questions. Thanks for the presentation. Thank you very much.
Yes, thank you too.
Okay, thank you, Alexander. Okay, our next topic is the architecture of online automated knowledge testing system, presented by Viktor Khavalko, Iryna Bilik, Alexandra Hasko, and Irina Protsik. Do we have any authors here? Because I haven't seen them in the list. Maybe I was mistaken. Okay, maybe not. Maybe there are some technical problems. Maybe we shall go to the next presentation, and then as soon as authors appear, they will let me know, and we will go back to their presentation. The next group of authors are Shportko Alexander, Bomba Andriy, and Postulati Veronika with their presentation. Do we have these authors here with us yet? Oh, Veronika, are you going to be the presenter of this topic, of this?
Sorry, what topic are you talking about?
It's the modified schedule of the algorithm LZ77.
Yep. Hello, I'm going to be a presenter, but I thought that I was going to present at 3:45. But okay, you can start.
Okay. If you can start, then please. If it's some problems, then I will check for the video presentation for our previous authors and let it on. But if you can start,
no, I can start, of course.
Thanks a lot. Thanks a lot.
Okay, please let me know whether you can see my screen and my presentation. Can you see it?
No. I can't, at least. I can't.
Okay. Let me try again to share it.
Mm-hmm. Oh, yes.
And now?
It's done. Yes, we can see your screen.
Okay.
Yes,
great.
And the presentation.
Thank you very much.
Mm-hmm.
Okay, let's start. So dear colleagues and participants of the conference, today we are going to present your report on the topic rejection of inefficient replacements while forming the schedule of the modified algorithm LZ77 in the process of progressive hierarchical compression of images without losses. Algorithm LZ77 is based on the replacement in the encoding process in the output stream of the sequence of consecutive literals of the buffer with the reference to a similar sequence of vocabulary literals in the form of a pair of number that consists of length and offset from the end of the dictionary. In the absence of a similar sequence of literals in the dictionary, sorry, I need to drink a bit of water. In the absence of a similar sequence of literals in the dictionary longer than 2 literals, the first literal buffer is transferred to the output stream without changes. After that, the encoded literals are transferred from the beginning of the buffer to the end of the dictionary, and encoding continues similarly until the end of the literals of the input stream. The same sequence may extend beyond the dictionary to the buffer area, but must begin in the dictionary. It's clear that the more and the longer replacements lengths of that can be found in the encoding process, the better the compression ratio will be. When decoding the codes of the LZ77 algorithm, individual literals are copied to the output stream without changes. Pairs, lengths of set, are decoded by sequentially copying from the end of the output stream at the specified offset to the end of the output stream of the required number of literals. On the first layer, we must consistently bypass pixels by the image, beginning from the first one on lines from top to bottom, and in each line from left to right with a step 2 to power k, when k is determined from the condition that you can see on the screen. On the next layer, from 2 to k+1, intermediate pixels of the image are processed in 2 passes. On the first pass, we must process those of them which are contained on crossing of diagonals of squares with vertices in adjacent pixels of the previous layer. On the second pass, unprocessed pixels are processed between adjacent pixels of the previous layer, and the first pass with the same step on the columns and with twice reduced on lines. To demonstrate the algorithm of processing, you can check the image on the screen. The symbol F indicates the pixels of the first layer. Symbol P, pixels of the previous layers. The number 1, pixels of the first pass of the next layer. Number 2, pixels of the second pass of the next layer. Pixels that have been processed before and therefore are not processed in the next pass of the layer are highlighted in italics. Sequentially placed data of the all passes form an input stream for encoding of LZ77 algorithm. The data of the next layer increases the number of processed pixels by about 4 times. Therefore, it's possible to stop the decoding process using the bypass schema after filling the output area without processing the codes to the end. However, the proposed sequence of the image pixel traversal allows not only to speed up decoding when the size of the output area is much smaller than the image size, but also to use hierarchical predictors to predict the value of each element of the pixel. To increase the efficiency of the LZ77 algorithm in the process of progressive hierarchical traversal on all layers, starting from the second, we will search for the same sequences for buffer elements not only in the dictionary, but also starting from the nearest previously processed pixels with the next layer. Because among the previously processed pixels, there is another pixel X, has the highest level of correlation with the nearest among them, the smallest 6 offsets with codes from 1 to 6 will be fixed on the nearest previously processed pixels. And to ensure the uniqueness of the decoding offset codes in the dictionary increased by 6. In the first passes, the 4 closest contiguous previously processed pixels are removed diagonally. See the figure A. These are the pixels from the previous layers. See the image B, and therefore they have large offsets in the dictionary. And the same sequences in the image that start with them can generally be scattered throughout the dictionary. The 5th and the 6th offsets for the first pass encode the nearest processed pixels of the same pass horizontally and vertically, respectively. But in the dictionary, the offset of the nearest vertical pixels is increased by the number of pixels in the pass line. During the second pass, the 4 nearest contiguous pixels are placed horizontally and vertically. See the image B. These are pixels from previous layers or passes. They are located closer to the next pixel than in the first pass, and therefore they start more identical sequences. Searching for the same sequences starting with the nearest previously processed pixels of the previous layers allows us to find matching sequences that are generally scattered on different layers in the dictionary and therefore are encoded on average by larger number of bits. The 5th and the 6 offsets for the second pass are diagonally placed and encode the pixels of the same pass from the previous line, but they have larger offsets in the dictionary. Symmetrically, pixels relative to pixel X of 4 offsets 5 and 6 are not encoded because they have not yet been processed in the next pass. As it was mentioned above, the modified schedule of the LZ77 algorithm should be formed in 2 passes. The first, to look for replacements among the nearest previously processed pixels, and the second, to find replacement in the dictionary for those pixels components that are not replaced by the first pass. We consider the algorithm for rejection of inefficient generated substitution of the modified LZ77 schedule in the last year report. In this article, we suggest substantiating the options for refusing or extending replacements in the process of forming a modified LZ77 schedule, which predictably increase the length of the code. In the process of forming a modified schedule of the LZ77 algorithm, it's likely that a longer identical sequence in the dictionary of 1, 2, or 3 literals, which without LZ77 algorithm would be encoded on the average of 4, 8, or 12 bits respectively, will increase additional bits of sets caused by 13. Thus, such extension of the replacement will be impractical as it increases the length of the code. The algorithm will reject with this extended replacement and return all replaced literals, but will not return the previous effective replacement. Therefore, inefficient replacement should be discarded both during and after the formation of each deflated block. When forming the LZ77 schedule for each pass, we discard those LZ77 replacements that are predictably encoded with more bits than individual literal. We calculate the predicted code length of literals and base length values based on the results of the preliminary statistical analysis. Let's analyze the results of the use of different variants for rejection of inefficient substitutions in the process of forming the modified algorithm LZ77 on the example of the progressive hierarchical compression of images of the AST set. The AST set you can see on the screen. The decoding time of the files obtained as a result of the application of these variants is almost the same, so it wasn't analyzed. On this slide, you can see the main characteristics of the images that were used for the test and algorithm modification. On this screen, you can see the results of the use of the proposed algorithm. We see that the analysis of the increments of additional bits of the offsets reduces the compression ratio of the AST set for an average of 0.01 due to the discrete tone images and photorealistic images with the same distant fragments. However, the effect of the algorithm at the time of the coding is not so homogeneous. On average, the ST coding set has slowed down by 1.11%, with coding accelerated by 6.7% for discrete tones and hence slowed for 1.6% to 9.7%. This is due to the previous rejection of inefficient substitutions, which allows the discrete tone images to leave more effective replacements and increase the number of short substitutions that are being found for the next pixels of hierarchical bypass. The best compression rates for the AST set are achieved due to the elimination of overlays of dictionary replacement for replacements of the nearest previously processed elements. Almost at the same time, the coding of compression ratio on this set has decreased by an average of 0.04. At the same time, the improvement of compression ratio is observed for 88% for the set files, but it's the most significant for discrete tone images and for the realistic images with the same distant fragments. The expected total reduction for compression ratio from the combination of these two options for rejection of inefficient replacement didn't occur because many inefficient substitutions from the dictionary due to the increments of additional bits of offset codes are superimposed on the replacements on the nearest processed pixels. Therefore, throughout the AST set, the maximum reduction of compression ratio from such a combination of 0.01 is observed only for the SAIL BMP. Conclusions. Reducing the size of, seems that I skipped this part of the presentation. A significant reduction of image compression ratio is achieved by rejection of inefficient substitution with the use of the predicted entropy code length. For discrete tone images, such as reduction is 0.02. However, the encoding time for images has increased by an average of 9.3% due to the calculations of predicted entropy code length for the AST set, which is unacceptable for standard modes of storing files in the graphic formats, which the rejection of inefficient substitution with the use of the predicted entropy code length should be used in archivers and to ensure maximum compression of discrete tone images, and in the standard mode of storing images in the format with the implementation of progressive hierarchical compression should be limited with eliminating overlays of dictionary substitutions for substitutions and with analysis of the increments of additional offset bits. Conclusions. Reducing the size of the compressed images considered by the modified dictionary algorithm LZ77 in the process of progressive hierarchical traversal is achieved mainly on the last layers, because the pixels that are used with the next buffer pixels have on average the highest level of correlation relative to the previous layers. It's possible to increase the efficiency of the classical LZ77 algorithm by additional search for the same sequences starting from the nearest previously processed pixels. Vocabulary algorithms significantly reduce compression ratio of preliminary artificial and discrete tone images because such images contain many similar adjacent sequences of brightness of the pixel components. Rejection of inefficient substitutions with the use of the predicted entropy code length should be used in archivers and to ensure maximum compression of discrete tone images, and in the standard mode of storing images in the format with the implementation of progressive hierarchical compression should be limited to eliminating overlays of dictionary substitutions for replacements and analysis of increments of additional offset bits. Further, in order to additionally reduce the file size of compressed images without losses and speed up the recording in the process of progressive hierarchical compression, we plan to improve the algorithm for reducing the size of the form deflate blocks using entropy code lengths, adapt the such compressions with other context-sensitive compression methods, and increase the efficiency of symmetric and asymmetric predictors using differential colored models. Thank you very much for your attention.
For the presentation, Veronika, very much. And again, excuse me for such a rush, 15 minutes earlier, sorry. Maybe there are some questions for, thanks,
yes,
for Veronika.
Sure.
Maybe I should ask, how do you feel, what would be the next steps of your research?
Yes, of course. So as I mentioned before here in this presentation, in the future, we plan, based on the algorithm, but based on the modification of LZ77 algorithm, we plan to use other color model model algorithm that will probably increase the compression ratio and will make our compression better.
Okay, thanks a lot. Can you use this algorithm to compress not only images, but let's say what else? Well,
videos, for example. So this video, of course, this algorithm is only for images, but video is a number of images that are changing one another, and
yes.
that's why probably it can be used for compression of videos, but probably it will not be so efficient as just for images.
I understand. So you are
it's just for images,
for images.
Yes.
Okay, thanks a lot, Veronika. Thank you very much.
Thank you very much.
More questions for Veronika and others? Okay, thank you very much for your presentation.
Thank you very much.
Thank you very much.
Thank you.
I was very glad to see you and hear you. Okay, our next presenter, our next topic is the human potential innovatization analysis, the system of crisis management determinants context, presented by the authors are Lyubov Halkiv, Oleh Veres, Igor Kulinyak, Yaroslav Kis, and Alexander Adamovsky. As much as I understand, Alexander is ready to give the presentation. Am I right?
Yes, but previous person doesn't quit. So we still see it.
Yes, okay. Veronika, would you be so kind to stop sharing the presentation? Maybe I am able to.
Can you kill my presentation? I don't know how to exit it.
Check. Okay, let's try like this.
Yep.
And
thank you.
Alexander, can you try whether you can share? Oh, yes, we can see your we can see your presentation.
So my name is Alexander Adamovsky. Nice to see you. That's really fruitful day. Looks like really interesting. From all kinds of presentation from different fields. But anyway, everything is interesting. But I would like to present a small article, small work of human potential innovatization analysis. The system of crisis management determinants contents. And I would like to start from the purpose and goals of our work. In this paper, we focused on building and testing methodological approach to analyzing differences in the levels of innovatization of countries' human potential. Based on this, we aim to prove that high levels of human potential innovatization prevent the crisis of the country's economy. We tried to do it, and I think we did it. So first, we tried to find out the dynamics of the area of publications volume for last few years, since 2013 till 2021, and we made two queries. One is human and potential and crisis in English-speaking Scopus articles. And another one was human and crisis, and Ukrainian speaking Google Scholar. And we see the interest and the number of publications is growing. So next, the methods we used, like from the Department of Management. So we use just general methods like content analysis to give the grounds for the feasibility of studying human potential, dynamic modeling to build the trends, and integrated evaluation to summarize the results, cluster analysis to identify the groups, clustering, and the regression analysis. No way to analyze the data without any kind of regression analysis. So first of all, let's remind what we mean. Let's explain what we mean by human potential innovatization, because usually we use the innovation word, but innovation is the innovatization we understand, because some people, when I interpret it, some people try to make the difference between innovation and innovatization. But so innovatization is understood as the process. So that is the process of its components transformation into those that can provide production, accumulation, translation, multiplication of innovations. So innovatization is the process. And then we, assessing the country's human potential level of innovation, we try to assess the country's human potential level of innovation in the context of crisis management. We have built a methodological approach. So on the first stage, it involves us an integrated assessment of the human potential innovation state in the form of an index. An index, IIHP, we call this, and we made it based on the values of the system of indicators that form the subsystems. And we separate three subsystems. One is educational component, one is knowledge and research. So that's the three subsystems of innovatization: education, knowledge, and research. And so educational subsystem, we took two components: education and higher education. In knowledge system, we found we separate four components, like results of knowledge and technologies, intangible assets, field of knowledge, workers, absorption of knowledge, and three components of research: cooperation between the university and the field of research and development, information and communication technologies, research and development, just in general. So what we got? The choice of components is determined by the ability of statistical information. The data is the basics for everything. And starting from this, we for last 3 years, we took 26 countries, starting from the the most developed country in innovation index, and finishing by not so developed like Uganda, Zimbabwe, and Bangladesh, as you can see. And so normalized values of the system of indicators of the research set of countries in 2020 looks like this. So we have 9 components of subsystems. We call them resource, educational, and knowledge, and 26 countries. We see 13 and 13 more. So all the normalized values. After we made the normalization, we found the integral assessments of an indicator subsystems and values of our index. And our index for 3 years looks like this in this table. So you see these components: educational, knowledge, and research for 3 years, and integrated index. You see for last 3 years. So the question is why we did it. We did it for to make the integral component like educational, knowledge, and research. We can see on the graphs for countries, and then we build it. We build the correlation coefficient between subsystems. As you can see, we have just ones. So correlation with themselves, we have ones on the main diagonal, and not so bad coefficients. You see the high levels of coefficients on the different relations. So our index visualization, we made 2- and 3-dimensional visualization of our index for last 3 years. And also we need to make a verification of our index distribution for normality accounting to the Shapiro-Wilk test for last 3 years, and it looks like this on this graph. And then we did all of this. We made the clustering. We made the 3 clusters with high, average, and low level of value of index, and you see the countries. It is actually where, as you can see from the names, from the countries, there is no such a lot of surprises for with this index. But anyway, we proved it by statistics to substantiate the conclusion that the countries with the high level of that index tend to further increase it. So they have high and they will further increase it. The method of 4-cell contingency tables analysis was used. Previously, an additional indicator P was introduced, which takes 1 if in 2020 compared to 2018 and 19, the rate of index change took a positive. So positive is 1, negative or 0 is twice 0. So you can see in table all the criteria, the Fisher's, the Kramer's V criteria and C criteria, all the regression. And the data from the analysis of the 4-cell table form based on the grouping countries by the value of our index of human potential that could be less than half or more than half, more equals, and the value of P are given in the table. So models of GDP per capita dependence of our index. At the 3rd stage, the last stage of our research, the impact of human resource innovation analysis on the economic crisis was carried out. The value of GDP per capita in dollars was chosen as an effective future for the regression analysis and purchasing power parity. So what's our conclusion, why we did it, and what's the conclusion of all of these? So first of all, the human potential issue is gaining popularity in research, as we saw on the first slide, of the scientific field crisis management representatives. In the framework of this area, the main focus is on the socially positive role of humans. What do we mean by this? The object of protection in a crisis prevention factor, and crisis management. In modern conditions, crisis-free development of country is not possible without effective innovation of their businesses. And despite the difference in approaches of scientists to the component structure of the human potential, in its structure, we can identify components that can promote innovative development. We call it 3 subsystems: education, knowledge, and research. In this research, we presented scientific results related to the construction and approbation of the methodological approach, or to analyzing differences in the levels of human potential innovatization in countries. In an empirical analysis of 9 components of the 3 human potential subsystems, according to 26 countries' data, the authors provided that there is a direct and tight connection between the integrated assessments of these components, but between the integrated components altogether. The authors also scientifically substantiate the generalized values of these components at the country level in the form of human resource innovatization index are inversely correlated with the crisis in economy, with the crisis. Based on the results, regression analysis revealed that the countries with the high level of human potential and innovatization are not only much more likely to increase the value of GDP per capita in terms of purchasing power parity. In addition, countries with the high level of human potential and innovatization are more likely to show a chance to further increase innovative human assets. Thank you for your
Thank you, Alexander, very much. Maybe there are some questions for Alexander.
Yeah, I would like to ask a question if it's possible. So
Yes, please,
as
Katerina.
indicators, I saw that you have been using education and higher education. So I have a question about the data. Where did you collect the data? And the second question, what is the difference between education and higher education? Because if education means the high school, so I'm wondering if it does it have impact of innovatization.
Thank you. That's really good question. Not as you can see from this slide, not high education, but higher education.
All right. Oh, okay.
Yeah, that's maybe my fault because I try to be quick, to be fast. And as I know, I didn't collect this part of data, but as I know, it's we choose 26 countries because we found this in open sources data. That's just a regular statistic data.
I see. So as much as I understand Katerina's question, it's whether the education has an higher education in it, or education is separately from
education at all, the basic education, and then higher education as like
I see. So the education means the basic education, the higher education is okay.
Two different criteria. Yeah.
Okay. So altogether they became education, but separately they are different education.
Yeah,
I see. Thanks a lot.
That was a good question. Yeah. Yeah. Thank you.
Yes, probably no more questions, Alexander. Thank you very much. We have your presentations. We can check on it again and contact you. Thank you very much. Our next presenter.
How can I quit? Sorry, how can I quit sharing?
I will do it for you.
Thank you.
I will just participate. Probably I will, or maybe I will not. Just
I can just quit the presentation.